Welcome to our lecture 19. Today we are talking about the chemistry of microbiology. This shall form our part 1 where we'll be talking about atomic structure as an important chemical aspect in microbiology. This is lecture 19 presented by Microbiology Biological Sciences. Kindly subscribe to our channel to stay tuned for more as they unfold. The chemistry of microbiology. Basic concepts of chemistry help in understanding fully the variety of interactions between microorganisms and their environment. Microbial chemistry is involved in the diagnosis of diseases, the purpose of the immune system, the growth and identification of microorganisms in laboratory, and the functions and selection of antimicrobial drugs, among others. Atom. Atom is the smallest component of a pure substance that exhibits physical and chemical properties of that substance. It cannot be divided into smaller substances without losing its properties. They interact with each other in a certain combination to form molecules. Living cells are made up of molecules, simple and complex molecules, that is. Atomic structure. Every atom has a centrally located nucleus and electrons that's negatively charged that move around the nucleus in regions called electron shells. Nuclei of most atoms are stable and do not participate in chemical reactions. The nucleus is made up of protons, positively charged, and neutrons that are uncharged. This thus makes the nucleus bear a net positive charge. All atoms are neutral. The number of electrons is equal to the number of protons, making the total positive charge of the nuclei equal the total negative charge of the electrons. The number of protons in an atom nucleus is usually 1 and above. The atoms are always listed by their atomic number and number of atoms in their nucleus. The total mass of protons, neutrons, and electrons in an atom makes an atomic weight or mass. The electrons are much less massive and are often ignored in the discussion of atomic mass because their contribution to the overall mass is negligible. Thus, the structure of an atom, it has the electron shells, then it has the protons and neutrons in the nucleus and electrons, that is on the electron shells. A matter that is composed of a single type of atom is called an element. For instance, gold as an element consists of only gold atoms. Elements differ with one another in their atomic number. For example, hydrogen, carbon, and oxygen have atomic numbers of 1, 6, and 8 respectively. Non-naturally occurring elements are 93, but only about 20 of them are utilized by microorganisms. Each element has its own symbol derived from its own English or Latin name. Isotopes. Atoms of an element that have the same number of protons with different number of neutrons in the nuclei are called isotopes. An example is carbon having 3 isotopes, that's carbon-12 with 6 protons and 6 neutrons, carbon-13 with 6 protons and 7 neutrons, and carbon-14 having 6 protons and 8 neutrons. Unlike carbon-12 and 13, carbon-14 are unstable due to the ratio of its protons and neutrons. Unstable nuclei releases energy and subatomic particles like neutrons, protons, and electrons in a process referred to as radioactive decay. Atoms that undergo radioactive decay are radioactive isotopes. Radioactive decay and radioactive isotopes are very vital in microbiology research, medical diagnosis, treatment of diseases, and complete destruction of contaminating microorganisms. Electron configuration. The chemical behavior of an atom is determined by its electrons. Thus, all the isotopes, e.g. carbon, having the same number of electrons behave in the same way in a chemical reaction, even though their nuclei are different. Electrons spread around the nucleus in 100 quadrillion times per second in an unpredictable three-dimensional electron shell that assumes different shapes depending on the energy of the electrons. Each electron shell can hold only a certain maximum number of electrons. For instance, the first shell nearest to the nucleus can hold maximum of 2 elements. Second and third can accommodate maximum of 8 electrons each, but the capacity of the third shell increases up to 18 electrons when the fourth shell contains 2 electrons. Electrons on the outermost shell are called valence electrons. Helium is placed with inert gases in the periodic table because its outer shell is full. Valence electrons play an important role in interactions between atoms. That's the end of our lecture. Next time we'll be talking about the chemical bonds and their importance in microbiology. Kindly subscribe to our channel to stay tuned for more lectures as they unfold. On the first slide, you saw our contacts. You can freely contact us for any questions or interactions or any assistance that you may need from us. Thank you. Bye bye.